Hi, thank you for attending EQengineered's Modernizing the Enterprise Monolith webinar. My name is Julian Flax. I'm CTO at EQengineered, and I'm the host of this webinar this morning. Appreciate you joining us here on this Tuesday. Please feel free to ask questions in the QA. We'll try to leave some time at the end to get to them. So this morning, we're going to be talking about modernizing the enterprise monolith, modernization as it affects some enterprise-specific notions we see quite often. I'm hoping that you hear some things that might be a bit of a fresh take on some of this, and maybe we'll have a bit of fun along the way. We'll be talking about some definitions around modernization, some trends going on out there in the Greenfield, and how we think about those in the enterprise, how they affect us, what challenges we have utilizing those, whether we should, and then we'll get into just some myths, risks, recommendations, and a bit of a discussion around there. But to change things up a little, I'm just going to start with an interesting build story that I like to come back to. What we're showing here is a very old structure. It is the pyramid of Menkaure, a pharaoh who lived at the end of the earliest phase of ancient Egypt. And this pyramid, it's not one of the biggest, but by all accounts, it was nicely made. Around 2500 BC, they can't be entirely sure too accurately there. But what makes it especially interesting is that about 3,500 years later, the heir of Saladin, for what I think were religious reasons, decided to get rid of the pyramids. And he began with this slightly innocuous looking pyramid. Maybe it seemed a good place to start. And after most of a year, what was succeeded in was making the scar, which you can see on the right-hand side of our screen. This took about 10 months, I think, and they found that they could move about 2 stones a day. They'd tumble out, they'd get stuck in the sand, and it turns out that it's almost as hard to unmake a pyramid as to make one. And I find that this resonates a lot with some of the intractability, some of the challenges we get when handling a large, serious enterprise product that's been around a long time. There's 2 reasons why I love this analogy. One is that this is a very understandable shape of a problem where in our own real enterprise challenges, we have structures and complexities that maybe one engineer in the organization has in their head that keeps them up at night. But it's also a great analogy because it's a demonstration of something real that happens with inflexibility, not because this pyramid was built badly and in a non-forward thinking way, but because it was built exactly the way it was meant to. And that's something that we see time and time again in enterprise organizations. So let's kick off with a little definition of what we might mean by modernization. Modernization is different for every project, team, and story that we see. But we can often say we are trying to improve technology productivity, performance, and velocity to enable growth and the ability of the enterprise to compete and thrive. And that last part is very important. It's really the whole enterprise we're trying to help. So outside of this narrow definition, we get into some pieces that more specific parts of the organization see. Mitigating risks of obsolescence, the engineering department knows all about that. Security vulnerabilities, there may be a CISO who's kept up at night. There may be a CFO worried because they've seen reports of what it could mean for the organization. But again, it's a slightly siloed view. And if you haven't had a security incident, maybe that's not going to be forefront of decision makers' minds. It can get us out from limitations and inflexibilities, and we'll see how that affects things more in some upcoming slides, along with the widening technology gap, a real technology case of the poor getting poorer. When you've got problems, it's easy for those problems to just compound. But the most important part of this slide is to just say, legacy technology problems affect your whole organization, even the customers. If there's a security incident, of course, then you have a very real brand problem with your client customers. There's people really losing faith in you. But it's much more nuanced than that. Every time we're fighting uphill against technology, budget is not ending up used as effectively as it could. Things that could be buying as flexibility elsewhere just can't. And chances to improve customer journeys through your product aren't taken or cannot be taken, not because we value them less, but because the ROI gets skewed by the legacy problems. So I want to step out just to talk a little about trends in Greenfield project architecture. And when we say Greenfield, we're meaning the opposite of what most of us contend with in the enterprise, rather than having a product which has built up complexity, use cases, happy users, and legacy problems. Some applications out there have just hit the ground, they hit it running, they're doing everything that's currently perceived right in architecture, and they can do it in a 300-line Hello World app and feel very smug about how maintainable that 300 lines is. It can be frustrating for those of us dealing with very serious large code bases where things are not so simple. But these are trends which are very significant, and whether they are the right choice for us or not, that's not the purpose of this talk. It's glib to overlook them, and it's certainly wrong to overlook them purely because we're looking through the lens of our own technology problems. So the first of those is microservices, which is essentially where we cut down an application's complexity, its functionality, into slices. This is done for two main reasons. One very famously espoused recently, early on, was actual business domain differences. Maybe a product spans parts of the business that fundamentally think differently about things or care about different concerns. But increasingly, it's become done for infrastructural reasons, meaning that you would like to slice the application up to keep the complexity down, to keep pieces that fundamentally only need to talk to each other via a simple message, only talking that way, so that you can leverage patterns of scalability and so on. Now, another piece that's happened increasingly is cloud hosting. People moving things to the cloud, it becomes a very attractive proposition, and it's something that's fundamentally changed a lot of our development lives. People are seeing the ROI of not hosting things on their own servers anymore, or even on their own share of a little server farm somewhere. And it's going beyond that. We're getting patterns now, whether you're talking Azure or AWS, you're seeing patterns where things like Lambdas are offered, where you can actually move parts of your functionality off the traditional notions of here is a server, be that stateful or not. A third notion that comes into this is multi-tenancy. It becomes increasingly desirable, depending on your product and your number of customers, to move things to a state where the same instance can deal with multiple tenants that must never cross the boundaries of seeing another tenant's data. Now, you can see how these notions end up living together in a lot of modern architectures. We split services up in a way that lets them live in the cloud. That cloud is able to fire up instances very easily and very cheaply. And if they are divided not by tenant, but by scalability concerns, that actually means that we don't need to suddenly fire up 10 services because we're bringing on one customer. We bring on maybe no new services for that one customer, except when the load gets bigger. And that can be the difference between people paying for a demo of your product or somebody in your organization clicking a button and adding a client. Now, if we assume for a moment that at least some of that picture is attractive to us, then we start hitting the problem. Well, okay, if I was writing my Greenfield Hello World, I've got no problems. But here's why we can't do that at our organization. We start seeing that in the case of microservices, if we haven't already thought about APIs for our product, or we've thought about them insufficiently, that's a problem. If we have outdated frameworks that maybe cannot cope with messaging in a modern way, or don't lend themselves to it, that can increase the challenges. And just compromises in our application architecture, be those from the outset or incurred over time, they can mean that the whole thing ends up a bit too cross-cutting to slice services off. Now that can be okay. We call this modernizing the monolith, not obliterating the monolith. Sometimes a monolith has a very good purpose and can meet the needs of some organizations. However, the other two pieces of these are a bit more of a universal ask. If you cannot move to the cloud, that is generally being perceived as an infrastructural compromise in a product. So what are some of the challenges getting there? Inflexibility of framework can be a piece of it, but a lot of it comes down to dependencies, baggage. Depending on what your product is and how it's made up of aggregate components, you can often have pieces that absolutely have to be hosted locally. There may be an OS that will not live there out in the cloud. There may be pieces of product it's connecting to behind the scenes. Everyone out there in the enterprise has experienced some of these, and they're as unique as every product is unique. Multi-tenancy is one of the biggest challenges. When we've hit multi-tenant asks on large enterprise products, it incurs a lot of soul searching when you come to the security questions of how can you reliably provide the security, the peace of mind that says, okay, 3 tenants can come in on this and they will never see each other's data. And that's the question that those tenants will be asking you and wanting some pretty confident answers on how they can trust you. Now, we've just talked about how a monolith may be the right approach. At EQ, we've seen some great examples where the perceived number of users, scalability, and so on has been actually very sensibly offset against some of the infrastructure costs of thinking purely from a scalability angle. It's certainly not a compromise to make lightly, but increasingly some people are sensing and asserting the value of doing things in specific ways to match their needs. But just as we said about how the microservice side of it is only one of the pieces of modernization we need to think about organizationally, we can say that there is a target where if we are going to stand by our monolith and look service-driven architectures in the eyes and say, this is modern, this is thought about, we want to be doing this, it should be able to think of itself as a mega service. It should be able to live inside a modern architecture. It should be able to get out of its hosting limitations and communicate with other services, be those splintered off pieces of that mega service down the line, or be that new functionality developed or acquired outside of this product. It should be as good a player as that Greenfield Hello World program. Otherwise, there's inherently a compromise going on, and one that could cost the business. So we have some general challenges to modernization. There are some things which are little red flags that will give you a good sense that this is going to be more taxing than less for your product. Is it documented and understood? This is a challenge so many engineers face and try to offset, but it's a very crucial one when we come to the question of, okay, how do we go and bring this into the modern age? Does it have good RESTful endpoints? And is it tightly coupled with the front end? Those two can go hand in hand, but RESTful endpoints, of course, are partly there to decouple front and back end, and they're also what lets other client services, or indeed applications in a platform, consume pieces of our data. Where those endpoints don't exist, it may not be so easy to provide them. There may be view layer business logic going on that we actually need to re-implement in the back end. There may be cross-cutting concerns that just make it very hard for somebody who isn't your application to consume that data. Lack of test coverage, obviously, any modernization, any refactoring is challenged by test coverage lack. If it's not built on up-to-date frameworks technologies, this is where you'll get some early unknowns you have to get through on a project. You have to work out, okay, what compromises does that mean in the design that we now have to overcome as we bring this up to date? Too much fragmentation or reliance on many tools, that's kind of the worst case of the above one. Maybe it's not reliant on a framework. Maybe there are processes being kicked off in your OS of choice, and there's a product running there that is being relied on that may become very difficult to rely on. Again, that feeds into the cloud hosting question quite often. Now, this is an early slide we threw together as we thought more about that front to back end API piece. People increasingly, a few years back, we found were thinking about cloud-ready strategies and decoupling the front end. And we were noticing across products using different technologies how much these languages were increasingly pointing themselves towards those approaches, whether it was the open source at large, some of the service-orientated or Spring side of the cloud-ready strategy, and on the Microsoft side, the .NET Core. But let's get a bit more into these two specific ones. The pieces that we've been doing most with and finding the most helpful in going forward are some of the trends we're seeing in Java and .NET. On the Java side, we have those cloud-first frameworks, and Spring is often perceived as, you know, it has a huge amount of uptake in the form of Spring Boot or regular Spring. There are some more scalable oriented microservice platforms, but Spring keeps coming back and asserting how ready for the cloud it is. And there's a whole Spring Cloud project that's very compelling. Injection patterns are something that we find are at the heart of good modernization. Injection, especially in the Java world, is something that's been followed for long enough that as we move from a legacy platform, you are likely looking at dependency injection code, and how we approach those dependencies very much drives how easy it's going to be to modernize. We use dependency injection to help decouple pieces from one another, and in a sense, modernizing your application monolith is the biggest case of decoupling there is. You're probably going to find some injectables are hardwired into your framework, but that's okay. The whole mechanism of injection means that we have a very logical route in which to map out our migration in a safe, comfortable way. JSR standards are something rather unique to the Java ecosystem. You see it more like on JavaScript, community standards really pushing things, but the JSR standards are so long-lived that people have tried to follow that a long time. And if the injection has been done using JSR community standards rather than proprietary framework ones, it can be a very helpful beginning to your modernization. The very fact that the code itself for final classes may not even need to be touched. It may just need new dependencies shoving in there. Especially if those are held behind interfaces unique to your application. Now on the .NET side, we're seeing more and more forward-thinking sides too. One of the big pieces, of course, has been .NET Core, breaking out of its platform reliance, but also more lightweight, kind of driving to that more lean startup time that we're trying to see as we talk about split services and living in the cloud. But another piece is injection is something which is kind of a bit of a second-class citizen in .NET. People have been using very good injection frameworks for a long time, but there was no standard for it. And the fact that .NET Core embraced that and said this is now part of the language has really taken it as seriously as those JSR standards did in the whole Java ecosystem. But the last one that's also not insignificant is just how well the entity framework, the ORM, has been maintained, continued, and recently really given a boost in terms of ongoing support for existing patterns. We've had this in the Java side, where most enterprise organizations I know have leaned towards the heavier ORM of Hibernate, and that's given a continuity. When we find ourselves modernizing an app that's Hibernate to something new, and the Hibernate's still using Hibernate, well, that's kind of beautiful. There's a whole data layer that is already in the pattern we wanted. And that's happening as people move from legacy.NET, if we're calling it legacy at this point, from 4.6 over to .NET Core. That entity framework side kind of comes for the ride, even though it needs maybe a few more changes than if it had been JSR. We have some questions that we think are always good to ask yourselves. One is, how well do you understand the need for modernization in your organization? That couples with what's driving the priorities. How far does the organization understand that it needs to modernize? How far is it understood where the problems are coming from? one of the sides there is it's very hard for an organization to be egoless, but also ruthlessly honest with itself about legacy tech. But it's crucially important because decision makers outside of engineering have to know what's going on. But another piece of that communication and the narrative is there an agreement on what good will look like? Are there competing narratives? You're never going to have everyone manning a keyboard in an engineering organization thinking exactly the same thing represents a utopic future, and nor should you need to. But when it comes to what decision makers hear, if there's too much disarray, it's a natural human consequence that people will hear noise rather than there is a ROI in modernizing this. So another question, is there good separation of concerns between layers, especially between front and back end? Some people have the luxury of acquiring a product when it comes to being honest about it. Other people have been gatekeepers, going through a lot of hardships and soul searching as they work out how to maintain a legacy product. Again, one just has to be able to step aside from who made it this way, why did they make it that way? The industry's changed, times have changed. There's no point asking why the pyramid was made that way when what you want to do is something different now. Again, is the code base organized, coherent, and documented? This does not drive whether we should modernize. It's just part of the cost and part of the challenge that everyone has to understand. And what are the best practices to retain and attract the right team and partners? At some level, an organizational question, at some level, an engineering question. Engineering feel the brunt of it because as you're manning a legacy code base, it can be harder and harder to find the people you want to join you. But it's bigger than that. Often partners are needed. That's where we get involved, obviously, at EQ. But again, throughout an organization, people feel the pain. It's very easy for a company to end up with a culture pervading it that things don't happen quickly here. We can't invent new products here. We can't change things. And there is actually a consequence of legacy that some people won't know is coming from the legacy code. They just feel the viscosity of the movement of new ideas. Here's some modernization myths I think are very worth talking through quickly. Now, I want to be careful about this. I'm in no way trying to be derogatory about very crucial things that do happen in the background. When I say that modernization can happen in the background is a bit of a myth. When there is a large-scale problem to do, it is not something that people can do by just being forward-thinking on every new line of code or spotting a few patterns. Refactoring has to happen. TLC needs to happen even if you're not modernizing. But when you have a real tectonic shift from A to B, that isn't going to happen by itself. Nor is it driven by poor engineering. Just like our pyramid, quite honestly, well-engineered, well-planned things eventually are going to get out of date. And there isn't an easy keeping up to date. Sometimes, if you're on a framework that is staying trendy and is getting regular updates, they will encourage in its best practice to keep up with those changes. It's very challenging to, especially in an agile-driven organization, but those are the best cases. In cases where the changes happen more wholesale as 8 years, 10 years go by, there's going to be a need for a modernization project. Myth 3, modernization can be delivered by a tech debt sprint or a percentage of a sprint. Some people try to put a number on modernization. Some people try to say, okay, we're not quite ready on some feature work, maybe another team's waiting to deliver as a dependency. Let's make this modernization. If you try to fit it in a sprint, you are going to get the engineer level view of how they can feel good about something that changes in a 2-week, a 3-week sprint and is deliverable. That's not how we need to think about it when we're talking real ROI. Much as those, again, are very crucial to do. Refactoring has to happen. Difficulty in estimation means modernization should not be undertaken. This is one of our biggest take-homes. Rewriting a project from scratch is the ultimate fate if it is never modernized. That is riskier than any modernization project I've ever encountered. You're trying to deliver all the functionality all at once. You're trying to do what's taken 10 years of product development all in one sprint, and it's very rarely a pretty thing. And the compromises made along the way often mean it's not quite as neat a greenfield project as you'd hope. So just think through. The ROI needs thinking thoroughly, and we often find the ROI is there. There are some risks we've talked about. Poorly documented requirements. Sometimes your requirement for a rewrite, as we say, is I want it to do the same as what happens now. Maybe QA know what that is. Maybe documentation knows what it is. Quite often they don't. Again, be honest with ourselves. Opaque areas of code, disorganized code. We're getting in the weeds here, but know they're a risk. So lastly, some recommendations. We keep these high level because every problem is unique. But here are some that I think provide good guidance for everyone. The architectural blueprint is fantastically useful. Know what it is. Know how it fits into your business strategy. I have no problems knowing I could drive to the West Coast from my home in the East Coast. I don't know how to do it, but I know a roadmap will get me there. Consider adopting DevOps best practices. There's been what's been called sometimes a democratization of DevOps. Development tools have met rollout tools, have met hosting tools. You cannot look to the future if your engineering department and your IT department are still maintaining traditional boundaries, I feel. A lot of the best ideas come from where they work on their tooling together and they both understand what can be done. And lastly, consider those benefits of deploying on the cloud particularly, even if right now you can't get there. That's how you start thinking about these ROI questions, because if you just assume you can't get there, maybe you don't even know what you're spending that you don't need to. So I want to thank you for joining us on a Tuesday. I hope you've got a good Tuesday ahead of you. And if you'd like to know more about this, please review our green paper, which we have on the Insights tab of our website. If you would like to reach out and chat about these problems, we genuinely live to chat about these problems at EQengineered. And please contact us via the website or directly at my number.